Welcome to the Startup Grind.
The Startup Grind. My name is Rich Foreman. And first off, I want to just talk a little bit about Startup Grind. Startup Grind is in, come on, advanced slide. It's in, we represent 2 million entrepreneurs. We are over 600 cities in 125 countries. And what we do, or what our mission is we want to give startups everywhere access to education opportunities to build, grow, and scale their companies. And we've had some successes. There's been a few, just locally here, we've had a couple events where startups met with other entrepreneurs. Not other entrepreneurs, but the investors. And one in particular was, we had one in Davis, and there was a bio startup that met Kevin Nagle, who eventually ended up leading their round. And also when we have our in-house events, that's where people get to meet. That's where connections are made, and if you need a CTO, that's where you may actually find a CTO. What actually makes us unique is our values. And when I first saw this, I thought it was really kind of corny, but as I've been doing this for many years, it really does resonate. So we believe in making friends, not contacts, believe in giving and not taking, and believe in helping others before you help yourself. And those are, Startup Grind's core values. So with this, I'm going to go ahead and give a slight pause to our startup queen, Laura Good, to basically tell us what's happening in the Sacramento startup community. And you're muted, Laura.
I'm trying to find links and do all this other stuff at the same time. So anyway, I'm Laura Good with Startup Sac, and there are a lot of exciting things going on right now in Sacramento's startup community. But two of the more exciting things is that there's 2 startup pitch contests that are accepting applications right now. And both of them have some major prize money. So the first is Pitch Elk Grove. You don't have to be in Elk Grove, but you have to be in one of 5 or 6 counties in the greater Sacramento region. And the first place is $10,000. Second place is $5,000, and third place is $2,500. And then, did I mention those applications are due this Friday? And then King's Capitalize in its 7th year. Those applications are due a week from Friday, which I think is the 25th. They've expanded their prize money as well. There'll be 3 prizes, a $10,000 prize, a $2,500 prize, and I think a $1,500 prize. So I'll go ahead and post the links. I'll also post the link to the Startup Digest, which comes out every Monday morning, and it's a roundup of the best events in the greater Sacramento region for startup founders. So that's about all I've. And we do have, I will say, Startup Sac has an event on Thursday called Being Deal Ready. It's during the day from 11:30 to 1, featuring Douglas Bosley, attorney at Witten Law, to talk about sort of having your house in order when it's time to do a deal.
When's the next startup happy hour? Startup Sac happy hour.
The next Startup Sac happy hour is a week from today. So I think that's the 25th. Is that right? Or maybe I don't have the date right. No, it's not the 25th. 25th, 24th, 23rd, 22nd. And the CEO and founder of Matrubials will be our featured guest. And Ashita will be able to talk about, I believe she went through Y Combinator. She's also in the Growth Factory right now. And she was also in Sacramento's female-led tech startup accelerator, Fourth Wave. So she'll have some exciting things to share. And it's a biotech company.
That's very cool.
Yeah, so I'll post some links. I just can't talk and chew gum at the same time.
And then for those of you joining, it was a big screw up, and I don't know if I'll ever live it down, but you probably joined in as Rich Foreman. So you could actually, if you want to, you could click on the three dots by your name and change your name. And I'm just going to give you, if there's anybody that would like, right now I can see Bob and David, if you have a startup, if you want to just do, we can give you, some, 30 seconds to talk about what you're doing. Does anybody here want to talk about what they're doing? And right now I just see Bob and Dave. And Bob, go ahead.
Yeah. So Laura's heard this, but we're off the wall energy, and we make a personal energy platform. It's basically a integrated storage element that's a UPS and a number of connectors. Think of a Tesla Powerwall, but not in your garage, but on your desktop, and on your desktop by your entertainment center and by your refrigerator. I always have this handy. Hang on a second here. Hard for people to grasp, but I have it kind of taped so I can take it apart. I've been doing some investorings. But this is a battery system. It's an octagon. It's meant to be set down in your home, and it stores energy. You connect it to the wall and you plug your other devices into it, and then you leave it alone, and it learns when your energy, you can buy it cheaper and use it during the higher rates for like time of use periods and stuff like that. Instead of having, if you're a renter or you have an apartment or something, you can't put batteries in your garage. You can't put solar out there. But with this unit, you can get some portion of your most critical devices with energy storage. And so you move, you get to up to 3 kilowatts, 4, 5, 6 kilowatts, as much as you want based on the demand of your end devices, not based on a greater demand. There's a whole lot of what we think are benefits for this, but just in the last week, I did an assessment of SMUD's current time of use rates. And, I'd like to work with some underserved or disadvantaged communities because we have a whole energy equity kind of philosophy in our company that we want to promote. And if we can give them 3 kilowatts of energy, 1,200 by the fridge, 1,200 maybe in the garage or office area, and 600 by their TV and entertainment. And those 3 kilowatts that they have available to them, you can plug a solar panel, you can augment it in different ways. But if they use that today with SMUD's time of use, it would pay off the unit in 5 years. It basically saves you about $565 a year. And then it has an 8 to 10 year lifespan. So if it's 8 years, you get about a $1,700 net positive benefit. If it's 10 years, you get a $2,785 positive. So we think it's a way for people who can't afford all those things or don't live in a home or some places where you can install that stuff, you have 25 grand to do it. You can buy these and kind of put them where you want them and grow them as you need more energy, and they're stackable for more energy. So that's really kind of interesting. And also this week, we got our first membership acceptance into the Solar Impulse Foundation World Alliance. So we're now a member and we're going forward for their sustainability label. It's a lot of work, but it's a great opportunity for us. So I appreciate the time to make this connection. And Rich, I just made a note here because when Startup Grind started, I was in Chicago, and when they first came to Chicago, and I didn't know we had really a local chapter here. How long has this chapter been in existence?
About 6 years.
About 6 years. I must have just
Well, I have that effect on people. Bob, like, how is that item in production, or is that why you're here trying to get?
No, this is a prototype item. So we have 2 or 3 of them, and they're working prototypes. And my engineers are primarily in Toronto. We leverage a lot of the Illinois Institute of Technology, some other people that we know, professionals, because my partner, Kadir Yosma, co-founder, he's put his great power expertise into it for his equity. I put my sweat equity, but I also funded all the process for it. And it's building multiple hardware layers. That was about a 4th generation 3D printed. We have a very sophisticated power board that's in there. You can change the amount of storage you have based on volume. You can communicate over the web, over the internet. It talks to smart speakers. So there's a lot of smartness built into it. And what we're doing now is we're moving forward on multiple paths for funding, not only foundation and grants, WeFunder, which probably in 3 or 4 weeks, and then a private Reg D, friends and family kind of round. Because when you get down to hardware and you're actually building it, it's not like software, right?
Right. Yeah.
Like, takes a lot.
How much are you looking to, like, when it goes to production? Well, how much do you foresee, or what's the target price for one of the devices that you're looking at?
So the device that I showed you there has 400 to 600 watts in it. And the target at the 400, it's 465, and at the 600, it's 695. So if you think about it, it's about $1.16 to $1.18 per watt that you put into the device. And so that's how you get to measure a number of these things that go forward. And then the 1200 watt system, 1.2 kilowatt, is $13.95. So, and the more, it's the cost of batteries. The thing that, and I presented this in 24 live demonstrations around the country, and it comes down to how long people think they want stuff to be backed up and what the price point is. And so that 465 price point for 400 or 695 for 600 has been acceptable, and people go, well, that's not too bad.
Yeah.
And and if you think about what a whole house energy storage does, they're a 7 to 8 to 15 year payback, and we're a 4 to 6 year payback.
Right.
And the real key is we're providing the power at the local power demand source, which is a 15 amp wall circuit, or even our prototypes with everybody involved has international experience in countries that don't have a lot of power. So you can take the prototype, you can plug it into any grid on the planet, and it will automatically recognize and configure for that grid. You plug a solar panel in, it'll run those electrons and don't pull any off the grid. So it's really smart. We're able to leverage we built our own energy management and battery management systems, so we extend the lithium ion life cycle by a factor of 8 to 10 years. So that really gives us a longer payback period. But the chemistries and the batteries to us are just a power source, so not too much more. So
you might actually, Laura, you might be have you presented at 1 million cups yet?
Yeah, a long time ago, 2+ years ago.
Oh, okay.
Yeah,
Oh,
here's the thing. It's only been the last 12 to 16 months that people really started thinking about portable energy storage. So in California, the CEC, the CPUC, CalC, everybody involved, they don't consider this energy storage because it doesn't connect to the grid, and PG&E can't reach in there and pull that energy back whenever they want. But we're 12 to 20% more efficient when you use our energy, and particularly 20% more efficient when you're in an outage period, because we don't have to cross that AC to DC divide multiple times, which you lose 6 to 10%. We do a whole lot of things to optimize the energy usage, which is quite different than kind of what the standard is. But.
Okay. Well, thanks for presenting, Bob. And I'm actually very interested. I'll probably follow up with you afterwards.
Yeah, well, I made a note. We'll follow up. I might do some things with startup to present, and we're gonna, the next few weeks we're gonna be real busy, but at the same time, that's just the way this life is. You're always really busy, right?
Yeah. So I'll just go over some housekeeping. And again, I'll probably never live this down, but I put in the wrong link. So everyone is signed in as Rich Foreman. So if you hit 3 buttons, you could actually change your name. Sam, actually, I talked to Sam, and he likes to have this presentation fluid. So if during the presentation, we'd ask you to mute yourself. But if you do have a question, you could just go ahead and unmute yourself and ask the question. Sam basically kind of likes that energy. And the common question we always get is, this is being recorded. So if you want to watch this again, we'll post it as soon as I get the recording of it. So with that, I'm going to go ahead and do a quick intro. This is Sam Miller. He's the founder and CEO of Ansync Labs. And I've known Sam for years. And I always call him a prototype shop, but he actually just corrected me today. So he's an research R&D shop that could also do manufacturing. I hope that I got that right, Sam.
That works.
Yeah. And he's, I've had a chance to actually had a chance to go to his facility. He's got like 40 people working there. He's done stuff like Bluetooth medical devices to drones, like full-on drones, and almost in many capacities. In fact, I just was working with another startup and that had drones, and I went to Sam because we had a drone question. So with that, Sam is going to be doing our main presentation. And then I'm going to go ahead and stop sharing and pass it on to Sam.
All right. Let's see. So, well, thank you very much, Rich. And thank you, Laura, for hosting the event. And as Rich said, I founded Ansync Labs about 20 years ago, where we've been in El Dorado Hills almost the whole time. And we do research and design and product development for some companies in the area and other companies in the Bay Area. Generally, there's a little bit spread, outside of that area, but mostly it's Sacramento area and Bay Area are our customers. And we do, in addition to the design work, we have manufacturing capability principally around our surface mount assembly line for electronics. And we also have a machine shop that supports R&D effort and from time to time does manufacturing work. But so the presentation today, so in that capacity, the questions I most get asked are around, how the form of like, how do I get my new idea built? So when I talked to, when Rich approached me about being a speaker, that was a topic that I suggested, as it seems to be the one that garners the most interest. So I'm going to switch to share screen here. See if this works. How are we doing?
We can see it.
All right.
Looking good.
So, still working?
Yes, it's still working.
Okay. So this is my my personal scorecard on the success criteria for hardware startups. This is somebody that's a company that's actually building something. So, 1 and 2 are very much in common with, every company out there. And in fact, you could debate about which is most important, but bottom line is if you don't have the funding, right, you're not going to make progress. Or if you're worse yet, you run out of funding before you reach the finish line. That's a disaster. Marketing is key, right? You have to be able to sell whatever it is you come up with. We all know this, and like collectively, the funding and the marketing problem, that's paramount. Then, after that, we're looking at design, and maybe the least important thing actually is the manufacturing challenge. But that's what we're here today to talk about, is the manufacturing portion. Next month, I think, Rich will correct me if I'm wrong, is we have my friend Jubal, who's runs Sacramento's premier industrial design company, that's going to be presenting, really the stages before what we're going to talk about today. So it's an advertisement for next month.
And I'll be speaking on the 15th.
All right, good. So, let's see here, make sure I got this right. All right, so this is the problem for hardware-based startups. I'm going to argue, and I think Bob alluded to this as we were getting ready, that there's lots of paths to building a prototype. 3D printing works great. There's lots of model shop providers out there to do garage level, very low quantity production. There's also a lot of great suppliers out there when you hit volume. So if the thing you've designed or you've come up with is going to be sold in Walmart, that's means it's headed for the 1 million unit plus mark. There's very capable contract manufacturers that will beat down your door to win that business from you. So we're talking about the second large portion of the ramp. That market is well served. And as a capable entrepreneur, you've you've been able to survive the first portion of the ramp. The real problem is this middle area. And, it truly is a disaster. So just to give you some idea of at least how I see the obstacles in this, it really revolves around cost. That a customer that's actually going to buy something, fundamentally, you have to be able to make it for less than they're going to pay for it. And everything is stacked against you as a hardware startup, chiefly because on any of these manufacturing processes, they involve some amount of NRE, or it's non-recurring engineering cost, associated with optimizing the process so that it can run efficiently. And you can pick anything. So the very simplest example is something like, we're all familiar with is plastic parts. Any given plastic part, the second piece, the second plastic part was very inexpensive. Maybe it was $2. But the first one, the one that was produced, 7 seconds before that part, probably cost in the range, we'll just make up a number. We'll say it's $30,000. Why was it so expensive? Well, somebody had to buy the mold. There's a piece, there's at least two pieces of steel that are very carefully machined that are what allow you to subsequently make plastic parts for sub $1. That's on the mechanical side, if you will. On the electronic side, you equally have problems. So in the US anyway, the model for procuring electronic parts revolves around a distribution chain. So anything you buy as far as your electronics go, there's a distributor that's targeting 30% margin on what their cost is. However, the people that are on the far side of that ramp that have made it, that are producing, that might be your competitors actually, are now dealing directly with a manufacturer, and they possibly have a cost advantage better than 10 to 1 on your price. And so, where do I get these numbers from? We've worked with consumer electronics companies where we're providing design assistance, and I had the opportunities to see their priced bill of materials cost, which it was just amazing. So they were getting the electronic components at 1/10 of what our regular customers, if you will, that were building in lower volume were. So everything is working against you for this middle volume. So with that, what we're going to talk about is this is the reason why a contract manufacturer it's not easy to find a contract manufacturer that's just going to go solve your problem for you, because you would like to stay as an entrepreneur, develop the idea, develop the concept, and have somebody else just take care of manufacturing for you. But because of all these obstacles, there isn't a market. So you're going to end up forced to solve this problem. So with that, I've got the list of questions that I get asked normally. These are not my questions, these are the ones that I get asked. And I guess I'd like at this point, if somebody else has a different set of questions, maybe we can figure out how to unmute you and ask them now, and we'll work to answer those questions rather than these ones.
Sam, it's almost identical to what I get in software.
Okay.
It's almost like, wow, it's pretty much the same questions that I get.
Maybe it's the same people. When they're done talking to me, they go talk to you. Maybe that's what's going on.
Maybe.
All right. Anybody else got anything they'd like us to try to address? Bob?
Yeah, Sam. So, like I said, yeah, we've been down this path. Unfortunately, my co-founder, he builds a lot of these things for major corporations. So we were able to get into that higher or that lower cost for production and really keep our bombs down for delivery. But one of the things I think in hardware is you really need to think about your design for manufacturing from the beginning, your design for your assembly, and your design for repair. And everybody along your chain that you work with, I use 3 different 3D printing vendors to make sure I got the right thing, and different players. But the other key is when you're building hardware and you think about going into molds, think about you're going to get the unit that you think. And then you got to think beforehand, we made a mistake. We forgot something. So plan for mistakes when you're going from that 3D printing to mold or other. Okay, well, we're going to have to cut this off. And then if I make a mistake, how can I adapt it temporarily to get what I'm going to need to go forward? And a lot of people don't think about that because, 15 to 30 grand is like the beginning point to build the mold, right? And then
Yep.
injection mold. So, but thanks.
Yeah, so
Everything here fits.
So my hope is that Jubal will cover some of those strategies. That's sort of like at the boundary. I'm not intending to cover any of all those great points that you brought up in the short time we've got here. But yeah, you make great points. So I'm going to stick with these questions, but I'm happy to talk about almost anything that's related to this if somebody wants to jump in at any point. So how much does it cost? I mean, the truth is, I don't have an answer to it. I can't know exactly how much your project is going to cost, but we'll just give you some high-level thoughts on that are relevant, if you will. So just to start off with, I bought one of these. This is sometime in the past, not recently. This is a Bluray Player. It's got image processing in it. It's got a little computer in it. It's got a motor. It's got a case. It costs $50. And I think you can pick one up in Rent or Revolve at the moment. This is also a board that I purchased, I don't know, a year or so ago that we had to do some image processing project. It's not quite as capable overall in terms of processing power as the $50 Bluray Player. It costs a bit over $1,000. So, and the Bluray Player you can pick up now. I guess these guys, I pulled this off of their website yesterday. It's going to take them 2 weeks to get this board to you. So, and both of these are fair prices. Walmart is making we'll say around about 15% margin on their stuff, more or less, but in that range. Xilinx, the company that's selling this, they're actually trying to promote the product that's on there. They're probably making no margin on this. So these represent pretty close to the cost of producing these things. And we could say to some measure, the Bluray Player is more capable and includes more parts than this board does. So like what's going on? And so this is like the goofy kind of chart that consultants love to throw up in business review. But we're talking about the individual components now. Let's say we're trying to get either of these products built or we had the opportunity to hear about Bob's product. We're looking to get portions, the individual components in Bob's product built. And we can look at kind of where they fall in these quadrants. So down the lower left, nobody is there. That's garbage. There's nobody that's building low sophistication, low quantity products. There's not a market for it. For that as a service. We're talking now about finding a vendor who we're going to pay to make the components for either Bob's product, the DVD, or that processing board. And where you are in this map determines the type of vendor and the costs. So the DVD player is actually moderately sophisticated but is produced in massive quantities. That's greater than 1 million units when you include all of the variants of that DVD player. That DVD player has different manufacturers' names on the front of it, but the guts are the same. The board, however, we might say is equally sophisticated, but it's produced in very low quantity. And so all of the question, the overriding characteristic as far as pricing goes is going to be quantity. So this eye chart, we don't want to go into this into real detail, but think of it as a list, and we'll refer back to some of this as we look through other slides here. When people initially quote a project, I'm going to use, Bob, if it's okay with you, I'm going to use yours just as an example because it's more interesting than the DVD player. So Bob is building what we might call it well, it's a battery system. So his battery system, the way somebody would initially quote it or look at the pricing is the bill of materials. And you might think of that as, from the perspective of the person putting it together, raw materials, right? They are not going to make the battery. We're not talking about the cost of lithium. We're talking about what is it for them to buy an 18650 cell, let's say, or what does it cost for them to buy this microcontroller? And that's initially where they get their first swag at pricing from. And then, not long after that, they're gonna start to include this labor number. Well, how many hours is it going to take to put the thing together? And then as they start to get bids for plastic parts, let's say, or extrusions, they've got these NRE numbers. It's 30,000 or 100,000 per molds for something on the scale that Bob is looking at. And so, they need to turn this into a final number. We're going to divide it by the quantity. So otherwise the number makes no sense. So Bob says, all right, we're going to do 2,000 units. That's how we're going to amortize these costs over 2,000 units. And then, so it is starting to, the number's going up, but it's starting to get more accurate. And then from the perspective of the vendor, so what we're trying to do is figure out how much a vendor is going to charge Bob. There's sales costs. So somebody has to answer the phone, answer emails, work through design drawings. They're going to supply some engineering on their side. That also we can say is going to be amortized over a quantity. And now we're getting pretty close. The remaining items, equipment, this is really what this is depreciation of capital assets that are used in the manufacture of Bob's stuff. So is it a robot? Is it a milling machine? Is it an injection molding machine? Ultimately, somebody's got to pay for that. Overhead, that's the factory, toilet paper, insurance, whatnot. And then so up to this point, a lot of what we're looking at here, because later slides we're going to talk about the overseas component or the overseas question. A lot of this, any of the items we talked about so far, there is a geographic differential that fundamentally they tie into labor costs. The raw materials, because it's passed through from another entity that's hopefully locally, geographically located, they're all benefiting from a lower labor cost. So the last three, I'm going to put in a separate category. First being risk. When you're buying something from somebody, it's never going to show up on a quote, but they're going to put a risk quotient in there of how likely the project is to struggle, to have problems. So the story there was I had a nice lady that used to sell kitchen cabinetry. And her story was, if she found out during the course of selling custom kitchens that her client was a lawyer, she added something like 20% to the cost of the kitchen. And her story was that she has no reason to learn that, especially in the first couple of times that she meets them. And she equated that to risk on the project. So similarly, this is, I'm bringing this up because it factors in later to some of the things we'll talk about is how do you reduce risk for your vendor? Shipping, this is an interesting component to anybody considering overseas, particularly in light of what's happened in the last year. And profit. It's important for you as a customer to make sure your vendor is making a profit. And people will look at it and say, wait a minute, that's less money for me. Yes, that's true. But you got to consider the scenario where the second time you go to place an order, and they are capacity constrained. And hopefully we'll have some time to talk about that, but it's important to make sure your vendors are going to make profit. Okay, so this is an attempt, so the question was, how much is it going to cost? And I gave a terrible answer, right? I just broke it down as far as what you're considering. And we'll weave in maybe more portions of this answer later on. Well, we'll try. Okay, I want to do made in the USA. That's how the question goes, or I've heard it that way more than once. Fine. I say go for it. If you're the scenarios where the marketing and the branding, there's a real value to made in the USA, and that you can price it such that the business works, I say go for it. In the absence of that, we can look at just some of the factors to consider. So we've talked, quite a bit about cost. That would cover these first two. The third is a little tricky, and this is, we'll say that over time, as industry has moved out of the US, what has left behind is a collection of high quality, specialized vendors. But by contrast, and I'm going to talk about China specifically because that's where I have the most experience, there's an amazingly complete supply chain. So in any given locale, there are multiple vendors producing custom screws, for example, and everything in between. I have here easier communication for domestic, for obvious reasons. There isn't the language barrier. I've taken some Chinese language classes. I don't speak Chinese. But I'm going to give the overseas guys credit for better communication. And this may come as a surprise, that in my experience, I think it has something to do with labor costs. They're able to devote resources to making sure that your questions are fielded quickly, as opposed to the experience that I'm used to getting in the US. And the little story that goes with this is I had a vendor that I'd worked with for always communicating with email for something like 3 years, and had never spoke to him verbally, never done a Zoom meeting, was always email. And I met him for the first time in China after 3 years, and it turns out he doesn't speak a lick of English. And what this is credits to is how good Google Translate is. And so this applies to him, and frankly, anybody else that you're dealing with. You'll find that they're able to use Google Translate extremely effectively, and they have the appearance of native speakers. The ones that don't are ones that are not using Google Translate and trying to do it themselves. And I think on balance, they're probably worse off. But so that's I'm trying to dispel any particular myths about communication. My experience is that they're better at the communication. It just may be a little bit more difficult in specific situations. Now I've got on the pro, I don't know whether we're calling it pros or a con, capability, availability. So what's happened in the US is manufacturing left. Let's say we talk about an injection molder that would have been running, let's say, 10,000 square foot facility in the US producing plastic parts for a number of different customers. They would have had a peanut line, a small production line capable of doing or working on new products. When that facility left and went overseas, so did the prototyping line. So there's significant holes in the US production capability as far as making things that have been very successfully done overseas. There are, however, specialty operations that didn't have the volumes to support the business model that's employed, again, in China specifically, and that remains and is specific to the US. So now we're on to things like this ITAR ISO 13485. This is stuff related to medical and defense. That's going to be difficult to do overseas. On the cons column, or something to be considered, is when you're getting excited about how much less something's going to cost you, you've got to, that has to be based around a model that doesn't require you to send an engineer over there to visit and work on the process. As soon as you start, paying for plane tickets and hotels, you might discover that some of your overseas advantage disappears. Other than that, shipping costs, we're going to touch on that at some point here. Tariffs, that's a big deal. Both of these are really in a whole new world from the perspective of the last 2 years. Credit or blame to Trump, and we can, and Biden hasn't varied it, so I think they can share the blame or the credit depending on which way you want to go. There's intellectual property advantage, obviously, to the U.S., and certainly a lead time advantage to the U.S. Okay.
Hey, Sam?
Yeah.
There was a question from Andrew. He's asking if he's basically was looking for a good source for U.S.-based manufacturers, and maybe you could answer it generally, or he just follow up with you afterwards.
Yeah. So okay. Well, that's. Thank you for asking a question, and let's anybody else who wants to jump in anytime, please ask questions. I'm going to jump ahead, and we're going to talk specifically about Andrew's question because he was brave enough to ask it. So I don't have a great answer for you, Andrew, but I'll try. So, finding vendors in China, we are using Alibaba. It's an amazing resource. The only problem with it is now that there's everybody on there. For U.S. manufacturers, it's like every other question you have. You're going to be using Google, and I'll add on YouTube as an interesting angle there. So now we're going to have a couple of different tricks that I can offer you as part of this presentation. Everybody is on the web, but it takes a bit extra effort to produce a video. So you'll find searching for manufacturers, even if you don't care about looking at a video, you'll find that there's you're down selecting by searching for vendors on YouTube. So that's the top one. Now the next set of tricks for finding U.S. manufacturers are what I've got listed below. So one is, we'll say trade show directories are somewhat obvious. So trade shows, like there is the International Plastics Symposium. There's the, North America glass vendors. There's, pick whatever it is. It won't take you much Googling to find the industry trade show for whatever that the particular thing you're looking for is. And in my experience, they do a very good job at publishing their exhibitor lists. So that's a good trick. The next trick is the suppliers to the suppliers. So the customers won't tell you who their suppliers are, right? If you're looking at somebody else's, let's say, battery backup system, they won't tell you who's making their circuit boards for them, right? There's just no way. But the other way around will work. So if you can go find the manufacturer that does the laser welding, let's say, of battery contacts, that builds that machinery. And then you ask them what vendors locally to me can you point me to? And so as long as you're not asking a question that makes it appear like they're playing favorites, I have found that the manufacturers of equipment that are being used to make the thing that I'm interested in are more than happy to share who their customers are. So like recent examples where we needed to do some specialized printing, it needed a specialized UV cure printer, large format. And we just called up the company and said, who have you sold machines to in Northern California that does job shop type work? And they were happy to share that. And you know, hey, please let them know that we sent you, kind of thing. And then the last one, competitors, that's a little bit weird, but you'll find at least for consumer electronics, you'll find that oftentimes there's a toaster company that's making 7 different brands of toasters that are all competing with each other. And you may be able to unwind that. But that's the best answer I've got for you, Andrew. But so we'll bounce back to the regularly scheduled program, but please jump in if you have a question. So this is just we're talking about domestic and overseas. Beware of, cultural biases. This lends itself to a story where I was looking at a Japanese. I've been to Japan to a trade show there, and we were it was a company that was making power PCBs with amazing power and cooling capability. And we found a project that was a good fit for it. And in sending them the collateral, it was exactly what they were presenting at the trade show. We were looking for a quote, and they says, no, we can't do that. And eventually discover through translation that the reason why they're saying no is because we've specified a color somewhere in the drawings for the printing on a circuit board that they don't have. And it was totally immaterial, right? Like it could be any color. So we cleared that up, and then we said it again, and they said, no, they can't do it. And so now we're a little bit bolder, like, well, why not? Well, because we'd specified a thickness as 1/8 of an inch, and the closest they had was 3 millimeters. So they can't do it. And that was not material either. But, eventually we got to yes. It took a while, but that was my experience in Japan. And I think that's not unique to me. My experience in China is the exact opposite. So it doesn't matter what you ask for, you get a yes. So you just have to, and I'm going to say that US is closer to the Japan side when we're talking to vendors. So we're really getting a no right up front. And it turns out it's a lot like an investor pitch, because in a way, they're in a similar role. Any vendor it's an investment in their time to create a successful business relationship with you. And so the bias initially is no, but you're working towards selling that you are going to be successful as a developer of a thing, and they're going to provide a key piece, and the relationship is going to be valuable on both sides. They are going to make profit, and you are going to make profit. So keep that in mind. See what we got next. Oh, I think we're still on the costs thing. So shipping, right? We covered shipping, or we're talking about shipping related to differences domestic versus overseas. So everybody's heard the news reports of how many ships are stuck outside the port of LA. That's a real thing. And it's causing a bidding war for shipping capacity. That's making, and what in turn has happened is in scenarios where a retail market had a fixed price for a product, distributors are choosing to simply not vend the product, to not import it, rather than either increase the price or lose money. So that's why you're seeing shortages of some like retail type products. So you're getting bidding war and shipping costs, and then I'm not sure exactly where it was in his term, but Trump introduced these 25% punitive tariffs on basically everything that was not politically sensitive. So how did I get onto this? We'll go back a little bit, but here's a cut and paste of an invoice specifically for a 40-foot container from China that I paid end of last year. So this is a piece of both questions. This is a piece of the question where we're asking how much is it going to cost, and a piece of the answer around, you know, do you want to manufacture in the U.S.? So, all right, let's move this up. So the big dollars here are $18,000 plus for the ocean part. That's where that big metal box is sitting on the boat. And in good times, we pay around $3,500. That's historically where we paid. So that's a huge difference. And this customs duty charge, you should assume we had something like $50,000 worth of declared value in that container, and we paid the government $12,000 in tax. And in previous life, that would have been sub 1,000. And you know, 3 years ago, there would also have been, we'll blame the sending end, but of course we're the beneficiary of it. The invoices would have been basically fudged so that everything appeared to have less value than it really did. And even then, the taxes were in like the 1 to 2%, depending on what the thing was. But now there's penalties involved such that the price of the goods is being accurately reflected in all the documentation, and the tariffs are in this 25% range. So this is a significant cost. Back to this slide. This is a container over on the right-hand side. This is me grabbing a picture that's supposed to represent either LTL or LCL. I think from my perspective, technically they're different. From my perspective, they mean the same thing, less than container load or less than truckload. This is a route where you don't have to pay for the whole container, but you're going to be waiting longer when it comes into port and they have to separate everything out of the container and make sure you get your piece. So that's making the equation around latency even worse. And then this route is interesting, is, you know, DHL can be surprisingly cost effective. You get an $800 per day, like free allowance, if you will, against customs duties. And so in 3 days, you can get stuff provided you're going to pay, you know, DHL air freight. And if you have a significant cost differential, you know, maybe it doesn't, DHL doesn't eat all of it, and you're okay. But really, in truth, this is the domain of prototyping or development. This is on the DHL side. When you're in production, you're going to send it by boat, and pricing will come back down. The tariffs, I suspect, won't, but I think the pricing for the ocean portion will come back down into the, you know, $3,500 range. All right. If anybody got any other questions, please jump in. You know somebody who can build whatever. And
I have a question.
Yes, go Bob.
Sorry. You had a $85,000 for insurance costs. Was that because it was related to the quantity cost of the product that you were shipping, or, you know, so that will, you know, it's really dependent upon the value of the goods you're shipping?
Yes. So where is that one? Import insurance charge, the $326, that one?
The third from the bottom, my graph show, oh, I see, 300 toward, okay. So the unit price is there, the 81,000. And so when you carry over, you only have 326. So I'm trying to understand, whereas in the customs charge and the freight charges, those carried over almost, 1-to-1.
Yeah, this is, so I think what you're saying is that I'm wrong, that I actually had $81,000 worth of declared value in that
Okay,
container.
that's what I get.
And this is the rate that I'm being charged if it gets stuck in the Panama Canal,
Okay, 4/10.
right? Or somebody
Okay, yeah,
sinks
great.
it.
Important. Thank you very much.
Yeah, this, I mean, this had the feeling of when you tick that extra box at the bottom of your car and when your rental car policy.
Yeah.
It's like, it's such small numbers and you're like, whatever. And you check it.
Yeah. Yeah.
I don't know. So, while we're digging into this, then like we've got origin local. So I'm spending $1,100 in China to get it from the guy that's actually collating it, if you will, from his doorstep to the port and the associated fees. And then on the local side, I'm spending $800 to get it from Oakland back up to my door in Sacramento.
Yeah.
So the next question, do we know somebody who can build whatever? We'll have a very nebulous answer here. Okay, well, I guess we've sort of covered this with Andrew's question, I believe it was. But we can go into a bit more detail. So I picked this because it was kind of funny on the English side. We've got a high volume self-sucking pump. This is your Alibaba website where it has basically too many answers to any given search, but this is step one. Unless you have like, existing relationships, this is your step one in searching for, I'm going to call step two in searching for vendors. And so, but in order to effectively use this website, I'm going to push hard on this strategy. So if you forget most of what I've told you so far, give this portion a second look. And what I'm saying here really is before you approach the vendors, get organized. So get the documentation together that describes exactly what you want. So because we have a great example from Bob, I'm going to assume that he's got some plastic case as part of the outside, or maybe it's an extrusion. He's going to create a package that includes his 3D model, straight out of his CAD program, a drawing. Now people will argue, well, I've given you a 3D model. Why do I need a drawing? Well, the drawing has the tolerances and the constraints that determine exactly how you can go about building the 3D model that's been provided. And then he's going to have some kind of indication. I mean, CMF is one abbreviation, but a specification around the color, the material, and the finish of the thing that he wants built. So this is your checklist on the left, and then just some gotchas on the right. So like, for God's sakes, do it in metric. Some years ago, sent a drawing out and it had English units in it. It's in inches. We got a very, very attractive price to make some glass components. Eventually, we discovered they were going to build something that was 25.4 times smaller than what we wanted to make. So it was a thing that was about 2 feet across, but they were going to make a thing that was 25 times smaller than that. So it was a very good price, totally worthless. The rest of the world uses metric. Unfortunately, it's the right strategy. Don't fight it. Just do it in metric. In the drawings, like if you ask a mechanical engineer to do the drawings, there's a chance you'll get a fully dimensioned drawing. That's great. But probably what you want is an inspection drawing, a drawing that lists those dimensions that you want them to check before they send you the thing, the things that really matter. It's the bolt holes, that interface with the thing that's going to screw into, or whatever it is that really matters. If you put, it's unrealistic to expect they're going to check every single measurement. But if there's two that really matter, put those on the drawing. There's probably another vocabulary word for this, but process dimensioning. So, or process tolerancing, really. You want to understand for any given process, what are reasonable tolerances. If you spec the tolerances too tightly, this is not, none of this is actually specific to overseas versus domestic. If you specify tolerances too tightly or not at all, you're going to pay for it. So just for example, a machined part, like an aluminum machined part coming off of a milling machine, they can generally hold 1/1000th of an inch all day long. So if you specify 1/1000th of an inch tolerance, they're fine. They don't care. Base pricing. If you specify tighter than that, you're going to pay for it. Something like an extrusion, aluminum extrusion, they can hold a couple of thousandths on one particular dimension. That's what they're going to tune it to. So if you try and put in many dimensions that are held to tighter constraints, either they're going to ignore it, or you're going to pay for it, or it's going to be a no bid. So, and then there's similar constraints with plastic of what they can control. So just you got to be a little bit smart about the tolerancing. And then this sounds really mundane, but it's tremendously valuable for whatever collateral you sent out. Like I beg you on behalf of your future self, have a part number and revision for this collateral, because you're at a communication disadvantage. Even if it's in the US, the partner that you're communicating with is dealing with many, many customers. You don't want the wrong version of your thing produced or quoted. And even if it's the only part you're ever going to make, come up with some part number to refer to it, rather than like main housing or something like that. And then the whole rest of the business process that's been worked out by, the world, if you will, since the Industrial Revolution, is tuned to dealing with the quantity of a part number at a price, and definitely have a revision in there. And then the last trick I'd advocate is don't underestimate the value of a picture or even a sample. So it doesn't cost much to send a piece of plastic. Let's say if we're talking about plastic and surface finish, anywhere in the world, as a definitive way of saying, this is the look that I want to achieve. So I'm talking about collateral checklist as a vehicle to getting quotes. So this is step one, is produce this collateral package. And then step two is dealing with Alibaba. And how are we for time? I'm going to burn through this. So this is the step three, if you will, and this does translate to Alibaba or even domestic. I'm going to call it 12-6-2. You produce your collateral package, you're going to find 12 possible vendors. And you're going to have a form email that you've constructed that says in very simple language what you're looking for and references the attached package. And you're going to send it to 12 vendors. And what will happen, I don't know, this is a law of the universe. And you can email me back if it turns out to not be true. You're going to get 6 responses. Why is that true? I have no idea. Six of the 12 that you've emailed are going to self-select out. They're not going to respond. And that's a good thing. That's why you produced that collateral package. They looked at it and they said, this is not business we want. And they've not responded to you. They saved you a bunch of time. You've got six responses. And then invariably, they're going to come back. In the course of those 6 responses, they're going to have additional questions. And you're going to iterate on these questions, improving your collateral package. Because if the collateral package was perfect, which it won't be, they would have no questions. but you're either answer them directly or improve the collateral package. And you will discover in the process that only 2 of these candidates are viable. Why does it work that way? I don't know. Only 2 of those 6 are going to be viable. And there's interesting things, possibly at play. You might discover that 2 of them are actually brokers, which can be a good and bad thing. Brokers tend to have more difficulty answering questions. It takes them an extra day to get the answer, and they're not as sharp with the questions they ask. Additionally, they tend to have higher MOQs, minimum order quantities. They're only going to do, it's 2,000 or nothing, because it's the cost of the sale to them, right? Versus somebody representing the factory, doesn't matter as much, right? They're a low-cost sales agent, and they're using the low quantity to win business. But you're going to have 2 that are going to be able to do, you're going to make it to the finish line. And early on in when I was doing this, I ordered from both, because in most cases, or at least early on, I was so amazed with the pricing, and I couldn't believe that it was actually going to work. I ordered from both, and I've never been burned. I got good product from both vendors. Now, we're only talking about scenarios where there isn't an NRE or it's very low. So other things you're going to look at as far as selecting vendors, of course, I mentioned MOQ, communication. You're going to get a sense right away of whether there's somebody that understands the business and is working for the factory, or somebody that's playing as a broker. Capability, can they do it or not? They're going to show you other product that's similar, and to help establish whether they can do it or not. Location, this is an interesting trick for my vendors. I always try and pick in the Dongguan region. So that's the mainland China portion around Shenzhen. And there's tactical advantages to having all the vendors in that same area, because I can then coordinate having stuff sent between them, and it helps with logistics later on. That's maybe an advanced level trick that you might employ. And pick any location. Maybe you're going to do, maybe you have familiarity with Mexico. Fine, you're going to do everything in Mexico. All right. That's the core of, let's see, we have, I'll throw this at you just by way of expectation. And if you go way back to my slide on domestic versus overseas, I mentioned cash flow. In almost all cases, the expectation in a U.S. company is they ship you the stuff, and then they send you an invoice, and you're on 30-day terms. So a month later, if you pay within a month, everybody's happy. In my experience, dealing with China, the expectation is at the time of order, you pay 50. And then when they are ready to ship, you pay the final 50%. And that comes in the format of them sending a picture of what they're going to send you, and you're expected to wire transfer the rest. So you are bearing the entirety of the risk. So if you're, back to the previous things we talked about, volume as an advantage on cost, if you're buying a ton of something, this is additionally working against you. For the actual mechanics of paying, PayPal I found to be surprisingly effective for very low, like during the prototype and samples phase. But there's Alibaba has a payment service. That's the only situation where a Chinese entity has screwed me was their payment system. So I'm a little bit resistant to that. Wire transfer has worked great. The only caveat that is tripped up, that I've been tripped up once with, and I know others have, is the U.S. banking system. The banks are very keen that you wire the money in the target currency, because they're going to make money on the exchange. none of the accounts, or when you get an invoice, it's in a particular currency. It's in USD. You're going to transfer in US dollars. Do not convert to Chinese currency, or clear that up, or otherwise they'll take a commission. They'll take the exchange rate coming and going because it will bounce off of the account. It's a mess. Another trick here is, especially during the early phases where you're prototyping, get quotes with the shipping. Ask them to include shipping to your final address. And the deal there is they're getting better rates. Or at least that's always been my experience. I can, the backup strategy is you give them your DHL account or your FedEx account, but it always seems that they got way better rates, especially if it's done as part of the initial request for quote than I can get. So always when I'm doing this, maybe it's done outside the RFQ process because it's part of a sample payment or something like that. I ask them to put it with the shipping and have them take care of it. They're just better at it. All right, I think we're kind of at time. The other things I have remaining are just an example of putting together this, what I would call not a supply chain, but a supply funnel based on this not hypothetical product, or we can call it, or people can drop off, or
Yeah.
I'm more than happy to answer any specific questions.
Sam, I'm actually okay with you continuing. How much more do you have, Sam?
Hours and hours. I can talk forever on this.
How much do you have with your presentation? Like a couple slides, or?
Yeah, couple slides.
Yeah, why don't you finish it off, and then if anybody has questions, they could put it in there. But let's just finish off the presentation. And
all right. So with that, this is I'm going to talk now about a concept I'm calling the supply funnel. Supply chain sounds cool, but it's not the way it is. When you're building something, you're starting with components and they get stuck together to make sub-assemblies, and sub-assemblies are getting stuck together to make, larger sub-assemblies, and ultimately something gets packaged together and it's a final thing. It very much has the feeling of a funnel. This is a product that we developed some years ago. This company has now been sold to somebody else. We still actually make a derivative of this, but I don't think I'm giving anything away by using it as an example. Let me see here. So we can talk about this as having, I guess we're really in the realm of backup slides here, but this product has, you can see the front and the back are injection molded plastic. The body of it is an aluminum extrusion. It has an antenna on the back for a wireless interface. It has a sticker on the front and the back to build the cover graphic. It has a silicone button for a navigation control. And internally, it has two circuit boards. One that's fairly simple that handles the display on the front, and a fairly sophisticated one that has the computer internally. And the way we organized this initially is I went out and I found, we did the design work. We went out and found suppliers for all the individual components, and then purchased them either, in some cases it was competing, like multiple competing antenna companies. We would have purchased the initial quantities and they would all been shipped probably by DHL. Some of it might have gone on a boat with another shipment to us. And then we would have assembled the first couple of hundred, maybe up to 1,000. And what I'm addressing here is what I started the talk with, where it was this disastrous middle piece of the ramp that's almost impossible to get past. So this is the recipe whereby we are initially doing the assembly that we would have liked to have, some magic non-existent contract manufacturer just take care of. So step one is we've designed it. We've created collateral packages for all these individual things. We've found vendors that are good at each of these things because that's the nature of manufacturing. Right? It's a high capital cost industry. Manufacturers specialize in some particular discipline because they bought the equipment to do it. So We've got, a big bag full of 1,000 of these little button controls. We've got another big bag comes from somebody else with the stickers, and the extrusions are packaged nicely, hopefully, and so on and so forth. That's step one. It all gets assembled here, and there's some small problems. What Bob alluded to, right? Some things just didn't quite work right. All of the circuit boards were done domestically. We iterated on those probably 5, 8, 10 times by the end of the project. But suffice to say, in the initial phases, all the circuitry was being handled domestically. And then the front board, the simple circuit board in the front, reached a level of maturity, and it was simple enough to begin with, that we were able to start gluing together our vendors. So initially, every vendor only had a relationship with us and shipped us the components. The next stage was we had the vendor that was supplying the graphic display send that part to the vendor that was making the front PCB, and we had them do the circuit assembly and ship it to us. And it was great. It was fine. And then we went to the next phase, whereas we had them, the guy that was doing the injection molding, we pay everybody sent it to the injection molder, and we used him as our assembler. He organized getting the PCB from the guy that had put the graphical display on it, and he puts it all together. Mostly it gets shipped to us, and we do the main board, the final assembly in QA in the US. And then, so I don't know what stage we're on. We'll call it stage 3 or stage 4 of this process. Then the next stage is basically we hand over all the vendor information to him, and he requotes it. And he quotes it basically exactly what we were paying. Now, did he go negotiate better rates with those individual suppliers? I don't know. Presumably, yes, maybe not. Who cares? But at the end, we do one wire transfer to him. He then goes and pays and manages all these suppliers that we found and we vetted, assembles the thing to 80%. We're now doing batches of like 3,000, 5,000 units. It's all shipped. It's a lot cheaper. It falls under the tariff code of a music player, which I don't think it's an accident that it's the same code that Apple products fall under. And so it doesn't receive the same tariff treatment. I don't think that's a coincidence at all. And it shows up, and we continue to do the final circuit board assembly because there's very expensive parts on there. And it ends up being a cash flow thing that we pay very little for the portion that's came from overseas. We buy on the demand from our customer, the expensive parts, build it, test it, and then ship it. And so this is where, if you can see me gluing together all these pieces with my hands here, ultimately we're only sending one wire transfer overseas. We get a shipment full of stuff. We do the last little bit of manufacturing in the US, and we deliver a thing cost effectively. And I recommend that approach. I think it works well. And it's the path across this production ramp problem, where a conventional contract manufacturer is not willing to take it on, and frankly, probably wouldn't do as good a job. So I think I have pictures related to that. This is me showing this thing of how it all glues together. By not showing it to you, I think you were listening to me rather than reading it. But on the right-hand side, there's other elements that I forgot. There's the packaging. Don't forget this thing has to be in a box, all that kind of stuff. And then this is showing it, where it joins the domestic supply side. And so, back to the original question about US versus overseas, this is a both, taking the high labor portion and pushing it overseas, and taking the high value portion or stuff that relates to payments timing, and doing it in the US. And I think that that concludes what my prepared slides.
Okay, thanks, Sam. Actually, I'm actually really glad after watching that. I'm like really glad I stayed in the software arena.
Yeah, if only I'd known, right? Well, maybe I would have been there with you.
So anybody here have any questions? Actually, it was just a lot of knowledge a lot of wisdom you gave to us, Sam. But anybody have any questions? There's one from Bob. Final quality, you get to control final quality. That's just a statement, I guess.
Yeah, Rick, that really wasn't a question. It was really a statement. Basically, when Sam's did the final assembly with their main PCB, you get to really get the final quality of your product and understand where it is before you ship it to your customers, right? So, and then, I really love the way you guys did this, Sam, because along the way, every one of those processes of getting all the components in bags and then putting them together, every time you do that, you're learning and iterating what the process and the components are in that concept. Well, if that screw hole was over 2 millimeters, we could have done this, and I wouldn't, it would take 2 minutes versus 50, and so you get to refine the whole assembly design process in this loop that comes to your final and then your delivery process. So it's great.
I mean, it was an opportunity to catch those mistakes and get the thing tuned up. And then when it was tuned up, then have other people, it worked just as way you're describing. So we use that project kind of as a template for all future projects. But it's replicatable. It's not specific to us. I'm sharing it with you guys.
Yeah.
You guys can do the same thing too, and I recommend it.
Yeah, and just a comment. Sometimes you have to get over, and sorry for monopolizing, but you have to get over mistakes that your suppliers make. So when our first main PCB, and since, we funded it to learn, they put a capacitor, instead of being a 90-degree angle, they put it straight up. And now all of our housing was off. We couldn't fit in the container that we had 3D printed. So it's like, you can get mad, you just get over it and say, okay, readjust. What it turned out is, once we decided we had to build our own battery packs because the retail ones were fighting our own BMS board, it turned out to be a blessing in disguise. We can now triple our capacity with the same board energy storage capacity. So serendipity, it worked in your favor. So, you just got to learn to iterate, work with your team partner, don't yell at each other. I'm a communications guy. My co-founder is a power guy. We use the same words, channel, controller, but they mean different things in a power environment than in a communications environment. And so you have to really work, in tight, close quarters and, come to real agreements when you're doing a startup and prototypes and you're building things. That element of communication and specifications and clear understanding is so important. So anyway, I love the presentation, Sam. I thought it was great.
Thank you, Bob.
Excellent.
Does anybody else have any questions? Looks like, Sam, just is there a specific horror story, manufacturing horror story that comes to mind you want to entertain us with before we leave?
Wow. I think of, we've definitely had scenarios where, well, maybe not a horror story, but we were having problems with glass, a very specific glass operation. And you can get surprisingly complicated with high temperature paint and how it gets processed. And we were backlighting a thing and it had to look a particular way. And I was over there for a week in China. And so day one, I went to visit that vendor because it was the most important thing that I had to get right. And so we walked through the manufacturing process and they outlined what they were going to fix and that, I should come back tomorrow. And, every day it was delayed. And then, come Friday, I'm going to be leaving on Sunday. Friday, we come back. And they had set up, and this was probably like 7 o'clock at night, and they're still working. And, the employees are still working on our project and other project. The boss is there. And, he's got it set up so that he can run it in all different variants so that I can look at it. And as I'm looking at it, we're pointing out problems, and he takes it away. And he runs another one, and we point out problems. He takes it away. And then I'm hearing this crash noise in the background, and I don't connect with what's really going on. But I'm looking at this next one, and it's getting better, right? He's got experts from all over working on this thing. And then I realize what I'm hearing in the background is as soon as he has somebody take it away, it's just being dropped in a dumpster. And there's just these huge panes of glass, just smash, smash, one after another. And then, finally we go to dinner and we come back and the employees are still working. But now it's good, or it's very close to good. I come back the following day on Saturday and, they had it. They'd figured out how to do it. But in the process, they threw away an amazing amount of material. And you were just hearing in the background, just panel after panel getting smashed to dust. But to their credit, they got it. And I'll say that like the entire crew in that facility, and I don't think it was specific to that facility, was really working hard. And
Well,
I
thanks,
don't know whether it's a
Sam.
horror story or just a testament to the manufacturing capability they have.
Well, thanks, Sam. Thanks for presenting today. That was actually, wow, quite informative.
Thank you.
Actually, I just saw in the audience, it's Jubal. Jubal, you want to maybe turn on your video if you can hear us? So Jubal and Sam actually work quite a bit. Jubal's industrial designer, and he'll be speaking exactly a month from now, or 4 weeks, on and the title is Designing It Right, Moving from Idea to Prototype. Jubal, do you want to say anything?
Yeah. Hi, Rich. Hi, Sam. Thanks for the excellent presentation. I was so tempted to chime in. A lot of our areas overlap, and we have all kinds of fun catchphrases for stuff. But great presentation, Sam and Bob. Thanks for all of the wisdom and insight that you also peppered in there. It made it fun. Yeah, I look forward to talking to everybody in a month's time about bringing your design ideas into a prototype and how working with a good industrial designer can help you span that skull and crossbones chasm there that was on Sam's early slide.
Okay. All right. Well,
I'm looking forward to it.
I'm going to sign off. I think dinner's ready. That's the beauty of being able to do Zoom meetings. You can just walk away and have dinner. So everyone have a great evening, and we'll see you in 4 weeks. Laura, thanks for presenting, and Bob, thanks for your input as well. So you guys have a great day. Oh, Laura? Oh, okay.
Just want to say goodbye.
All right. Bye, everybody.
Thanks, everybody. Have a good evening. Bye-bye.